Hello. Today we're going to be looking at chapter 3.1, which is quadratic functions. So in previous chapters, we've looked at the quadratic equations. And we've even looked at how to solve quadratic equations by either completing the square or using the quadratic formula. But now we're going to be looking at a function instead of an equation. So we have some function, and this function is a quadratic function, so it can be written like this. Any function that's written like this where a does not equal 0. Other than that, a, b, and c can be any real numbers. So square root of 2 x squared plus 1/2 x plus 3 is a quadratic function because a, b, and c are all real numbers. Now, what is not a quadratic function is if you had something like this or something like this or some different power, etc. Those would not be, but this is, so it's a quadratic function. It's any function that can be written like this. Now, you do know a couple of these. You know one in particular quadratic function. That's the function f of x equals x squared. You know what that looks like? It's a parabola. Looks something like this. Okay. And we even know how to do translations on this. We know if we multiply, say by 2, then the function will accelerate more quickly. It'll look something like this. So there's 2x squared. We even know how to move it. Let's say we want the function over here. We know how to do that. If this was h and a rise of k, so we're moving it over h and k, then we would know that we take the function x minus h squared plus k. That's a movement of h of k translation. And then we know how to do a number out in front, which kind of leads us to the standard form of the quadratic equations. The standard form quadratic equation is any function, any function that can be written like this, as in standard form. So we can take the above function here, the ax squared plus bx plus c, you can complete the square and get it to look like this. And this is known as standard form. And it's kind of the most useful form when it comes to quadratic functions. Just like the mx plus b form for linear functions is the most useful form. This is kind of the standard form for the quadratic. And all quadratic functions are parabolas, okay? And there's kind of two things that we need when we're looking at a quadratic function. We need a. We need to know what a is. If a is greater than 0, then it's concave up. Hence, it looks something like this. If a is less than 0, it's concave down. And hence, the function will look something like that. Okay, so we need to know a, whether it's positive or negative. And it helps to know the vertices, because the vertices, which are your h and k, they will either be your lowest point, if it's concave up, here's your vertices, HK here, it's going to be your min, or it'll be your max if you're concave down. So here's your H and K, the vertices. It'll be a max. So that's the other thing. We also will note that if you're to draw a straight line through the vertices, that all these functions are symmetric with respect to that vertical line through H. Okay? So if you have some H and K, you know what it is. Here's your H and K. Let's say it's concave down. Then we can draw a vertical line through H there. And this side of the parabola going down will be identical to this side because it's symmetric with respect to the vertical line through H. So those are the things that this tells you. So looking at this, the important things are here and here. That tells you the vertices. And the vertices tells you where this line that the parabola is going to be symmetric to, and also where the highest or lowest point depending on A. So that's the other thing we need. A tells us whether it's going to be concave up or concave down, whether it's a min or a max, depending on whether A is positive or negative. So those are the two things that you kind of need in order to do this. So let's go through the procedure of how to graph a parabola. So the procedure for graphing a parabola or quadratic function, if you will, which is a parabola. Step one is you identify whether it's concave up or concave down. By finding out whether A is greater than 0 or is A less than 0. Here, if A is greater than 0, you're concave up. If A is less than 0, you're concave down. Okay. So concave up means smiley face, concave down means frowny face. The next thing you can do is you need to identify the vertices, or the vertex. Okay, not the vertices, the vertex. The vertex is your H and K. It tells you your minimum point, tells you this point here or this point here. It tells you where you have your diagonal or your up and down line that you are symmetric to. Okay, so that's the second thing you need to identify before you graph. The third is you need to find x-intercepts if they exist. They don't all exist. You do that by setting f of x equal to 0. And then find your y-intercept by setting x equal to 0. And then 5 is you use a t-table and the symmetry property to get more points, and then you graph these points and play connect the dots, and then graph. Okay, so let's do this to graph a function. So we have this quadratic function here. Okay, it's already been put in standard form, and I'll show you how to put it in this form later, but for now let's just look at getting these. So number one, we need to know what our A is. Our A equals -2, which is less than 0. So since A is less than 0, we know we're concave down. So down. Concave down or frowny face, all right? Number two, what's our vertex? Well, our vertex is going to be +3, +8. Now remember, when we're talking about translations, when you're doing a horizontal translation, it's always the opposite sign. So because we're negative here, that means we're going to be plus here. Okay. Now, up and down, vertical translations keep their sign. So it's positive because it's +8. If it's been a -8, it would have been a negative. So just remember that. Okay. So that's our vertex. And we know that we have this line at x equals 3 that is our line of symmetry. Okay. Number 3 is find the x-intercepts. So the x-intercepts are when the function equals 0. So set the function equal to 0 and solve it. You're going to subtract 8 from both sides. Then divide both sides by -2. Then use the square root property of both sides. And when you do that, don't forget your plus or minus. Here the square root and square cancel, and you get x minus 3 equals plus or minus 2. Then split it up into two parts. So you have x minus 3 equals positive 2, and x minus 3 equals negative 2. Add 3 to both sides. Add 3 to both sides. Get x equals 5 and x equals 1. So there are your intercepts. Now, you don't always have intercepts. So just be aware of that. You don't always have x-intercepts. You always have a y-intercept. So we'll go ahead and find that. Find that by plugging x equal to 0 in the original function, which is here. So we're going to plug 0 into x. That'll just make this -2 times the square of -3 plus 8. So that'll give you -2 times 0 minus 3 squared plus 8, which is -2 times 9, because -3 squared is positive 9 plus 8. And then this is -18 plus 8, which is equal to -10. So we know our y-intercept is at 0, -10. Okay, so that gives us our intercepts. So far, the steps we've gone through is we found our A, we found our vertex, we found our x-intercepts and our y-intercepts. Now the last step is to do this t-table. So what you do when you do the t-table is you're going to have your x values and your y values, which are f of x. And I always put the vertex in the center here. So our vertex, again, is 3 and 8. So we're going to put 3 and 8 in the center. And then I'm going to go down a couple units. So 2, 1, 0. And then up the same amount. So 4, 5, 6. Okay. And that will give me a broad range. And because I'm centering it, putting the center is as the vertex, we know it's symmetric. So whatever the 2 is, the 4 is going to be also. So we only have to plug in half the number. So we plug 2 in to the original. Well, let me write the original function. It is 2x minus 3 squared plus 8. So plug 2 in, you're going to get 2 times 2 minus 3 squared plus 8, which equals 2 times -1. This is -2, by the way, if I remember right. Yeah, -2. Plus 8. So -1 squared is 1. 1 times -2 is -2. -2 plus 8 is 6. So this is 6. Because of symmetry, and because I've lined up your vertex right here, that's your vertex, I've lined it up, I will know if I plug 4 in that I'm going to get 6 as well. You can go ahead and try it. Plug it in. That'll give you -2 times 1 squared plus 8, which is, again, 6. So by symmetry, I could have just put 6 down there. Now I'm going to plug 1 in. So you plug 1 in, you're going to get -2 times 1 minus 3 squared plus 8. So this is going to equal -2 times -2 squared plus 8, which is going to be -8 plus 8. So this is 0. Okay, which we could have, I guess we already had that. We knew that it was x equals 1 equals 0, and we know that 5 equals 0. And we know that 0, x equals 0, we already solved that. That's -10 there, which means by symmetry, this will be -10. So then we have our t-cell. I'm going to go ahead and write it at the side here so it looks more clearly instead of doing my calculations. So you have 0, 1, 2, 3, 4, 5, 6. This is negative 10, 0, 6, 8, 6, 0, negative 10. Now we can go ahead and graph it. Now that I have my t-chart. Seven, 9, 10. So that's 10. So now we have our line of symmetry is at x equals 3. All right. So here is, I'll go ahead and put a red line in. Here's our line of symmetry at 3. And we know that the vertex is at the point 8, 3, and 8. So there's our vertex. And then we just follow, so I always label the vertex first. And either side, it's just going to go down. So next we go down 1, which is 2, and then you'll get 6. So you'll get here and here. Then we go down to 1, and you get 0, which is here, and then 5, which is 0 there. And then you get 0, negative 10, negative 10. So I just graph those points. And then I can connect the dots. And notice it's symmetric with respect to the red line, but we really don't want the red line, so I'm going to erase it now. But there is your parabola using this method. So again, what do? Back up. We found our A. The A tells us whether it's concave down or concave up. Then we found our vertex. Then we found our x-intercepts, then our y-intercepts. Remember, you don't necessarily have x-intercepts. So sometimes I leave that step off and then just put them in. They'll show up maybe in the step 5. Then I do my t-chart. When I'm doing my t-chart, I put the vertex in the center and then go up or down by units of 1 and then find the other points and then use symmetry. Because it's symmetric, you only have to find one of the groups, you can label the other. Then I graph it. Okay? So that's graphing a parabola or this quadratic function. Now, however, moving on, what happens when they don't give us to it in the standard form? What if they give us something that's in the general form, in this form here? Okay, then what do? Well, then you have two methods. You could do completing the square. And if you complete the square, then once you complete the square, you'll have it in standard form and you follow those steps. Or you can do just, if you're just interested in the vertex, there's a method to use that will only find the vertex. So the two methods are either completing the square, so you have it in standard form. That'll put it in standard form. Or if all you're really interested in the vertex, because you're just interested in whether there's a min or a max, then there is this formula. Your vertex will exist at this point here. Okay, so you can use either of those two methods. I'm going to go through both of them. I will we'll use this problem here. As an example. Okay. So let's complete the square. Now to complete the square, we're going to complete the square using a slightly different approach than we did in the quadratic equations. Because with quadratic equations, we could add or subtract things to both sides. Here we can't do that because we don't have both sides. So but it's still a process. So the first step is you put your parentheses in on the first two, like that. Make sure if there's a negative, it stays inside the parentheses. Then you factor out this a here. If there's an a, if there's something in front of the x squared, you factor it out. So that's our second step. It's factor out. We have a negative, so we're going to factor it out. I'm going to leave a blank space. Okay. Then that will have been like that will be I just lost my train of thought. Sorry. Will be like dividing everything by your a. That's kind of the step we're doing here. Now you're going to complete the square inside the parentheses. Well, to complete the square inside the parentheses, you just take the middle number divided by 2 and square it. So the middle number divided by 2 is 2. So 4 divided by 2 equals 2. 2 squared is 4. So you're going to put a 4 there. But you can't just add a random 4 anywhere. And this is really not a positive 4, it's a negative 4 because of this negative outside here. So since we added a negative 4, we need to add a positive 4. So I'm going to do that here. And the reason you can do that is because we've subtracted 4. And then if we add 4 back, they cancel. See, this and this will cancel, so we're not changing anything. And because this is a negative 4, and it's a negative again because of the negative out in front, then we're going to have to add a positive 4 to the side. So that's the reason we've done that. Okay, that equals 10. Now you're going to factor the x squared plus 4x plus 4. And that factors down into, it's a perfect square polynomial, so it factors into x plus 2 squared plus 10. Now notice that it's in standard form. So we know our a equals -1, which is less than 0, so it's concave down. And we know our vertices, our h and k, vertices is -2, positive 10. It's -2 because, remember, it's always opposite side on the inside. Right there. So that's our vertices. And then at this point, you could graph it following the same techniques we did earlier. Well, so that gives us our vertices and it puts it in standard form. Let's say you don't want to go through this procedure, you just want the vertices. Well, then what you're going to do, so let's start over with the original problem, which is f of x equals -x squared minus 4x plus 6, is we have this formula that the vertices is -b over 2a, and then f of -b over 2a. So what you're going to do is find what this -b over 2a. So we know b is -4, a is -1, so plug them in. So -b, so you're going to have a double negative here, once from the formula, once from the number here, and then divided by 2, and then another negative from the a. This will return -2. So that tells us the x coordinate is -2, which we already knew. Now to figure out your y coordinate, you're going to plug, that's what this f of -b over 2a is, you're going to find f of -2. You're going to plug -2 into the function. So -2 squared minus 4 times -2 plus 6. Okay, this is negative. This would be 4 plus 8 plus 6, which translates to 10. And then we know our vertices is -2, 10. Okay, and then we could graph it similarly, but we'd have to use this version of the function here to graph it. We still know that it's concave down because of the -1 in front of the x squared. So we still know, we can still have our a. We know our a equals, a equals -1, and we know what our vertices is. Okay? So we know it's concave down, and then we would just go about the same steps. So there's the two different methods of using. One using this formula, which I'll circle in red here, which if you're going to use it, you're going to have to memorize. The other is completing the square. They both return the same information. Okay. So let's continue looking at examples. I want to look at a couple practical examples here. So what this vertices, there's a lot of examples using these types of functions, okay? In physics, in economics, and spatial engineering, lots of different engineering. Anything that has a parabola. And gravity tends to make objects fly in a parabola when you throw them. So throwing a baseball, shooting a gun, etc. So what we're going to do, let's do example problem. So a guy throws a ball, and it follows the path, this path here. Okay. So here's your height. This is your height, this is your y, and x is your horizontal distance from the point. So he's here, and he's going to throw it. It's going to travel like this. Here's your x is your horizontal. So it's going this way is your x, and your f of x is your height. Okay. It does this path because of gravity. You have some initial velocity. I get into the physics of it, but basically you have this equation, and they might want to know a couple things. They might want to know, well, number one, they might want to know what's the max height. Your max of f of x, the maximum height. Forgot my e there. Maximum height. Well, because we know that our a is negative, here's our a here. We know it's concave down, which means we know it has a maximum, and the maximum is the vertex. So what we're going to do is just use the vertex formula here. So our vertex is this formula, negative b over 2a, and f of negative b over 2a. And you're going to plug in b is 1.18, so it's negative 1.18 divided by 2 times negative 0.01. Okay, and when you work this out, double negatives will cancel. You end up, I think, if I remember right, with 59. So say this is in feet, so 59 feet. Now this tells us the horizontal distance. It tells us this coordinate here of the vertex, but it wants to know what the height is here. So to figure out the height, then we have to plug in what's f of 59. We're going to plug that in to into the equation. So you're solving this and if you work this out, I think it comes out to be approximately 38, I think, 36 or 38, somewhere in that range, feet. And that'll give us your height. I leave it to you with the calculator. I don't have a calculator present. So that'll give you your height. Okay, now let's say they want the maximum horizontal distance. So we have the maximum height, 38 feet. Well, the maximum horizontal is going to be double the x coordinate for the vertex, because here's the halfway point. We know this is 59, so if we double that, you get, say, 108. Okay, 118 if it's 59. And this math might be a little off. Again, I don't have a calculator. But the whole process is you plug it into here and you work it out. Okay. Another problem is you have a company that has a cost function. This cost function looks like this. And you have a revenue function that looks like this. Okay. And you want to know what your profit is. You want to know the profit function. Well, profit is always equal revenue minus cost. So you put those in there and you'll get your profit equation is 20x minus x squared over 1,000 minus 16x minus 2,000. So I plug in my revenue and cost. Then I can combine like terms and reorder it. To get this. So here's our profit equation. Now, X is the amount of units that we're producing of something. This right here is known as your price. Okay, X is units. Here's your variable cost. Here's your constant cost. And they want to know, so this is a pretty typical standard economics problem. And you're a company and you want to figure out what you want to maximize profit. Well, looking at this, we know it's a parabola. We know it's a quadratic. And we know it's concave down because it's negative next to the x squared. So we know it will have a max, and the max is at the vertex. So then you find the vertex. You use the same formula. You use this negative b over 2a, and then f of negative b over 2a. So then b is 4, a is 0.001. Okay, and we plug them in, so you have 4 divided by 2 times 0.001, and they're both negatives here and here, so the negatives cancel. And when you work this out, you're going to get 2,000. So 2,000 units will maximize profit. Well, what's the profit? Well, that's when you plug in your 2,000 into the original function. So the maximum profit is at 2,000. And when you work this all out, you'll also get 2,000 as your profit. So say $2,000 is your max profit at 2,000 units. So here's where these types of problems come in handy, where the vertex comes in handy. That's it for this lesson. See you next time.